Nitrogen rejection unit, as it is obvious from the name, is a unit that is used to remove nitrogen from natural gas. Okay, so the function is to flash off or remove the nitrogen from LNG product, which is produced in the main cryogenic heat exchanger, or MCHE, and pump it to LNG. So we have our LNG products coming from main cryogenic heat exchanger. So this unit, the nitrogen rejection unit, is a unit located after MCHE, after main cryogenic heat exchanger. So once the LNG product that is majority methane is coming out of MCHE, before it is pumped to LNG storage, it goes to a nitrogen rejection unit where the nitrogen will be removed, and then it will be sent to the LNG storage tanks. So I put one link here for you. I can say it's a useful link. Is I think less than 2 minutes. You can just watch it for your. It's for your information if you need to have some additional information. But the process that they explain here is different than the one that we have in this lecture. Okay, so it's just for your information, like how the process look like in general. So the purpose is to remove nitrogen from LNG before we sell it. So in this way, we can enhance the calorific value of the natural gas. Less nitrogen in LNG, it means the natural gas has higher caloric value, heat value, and also maintains cell gas quality. So this is a quality that the customer is asking us. The customer is asking for a certain amount of nitrogen, less than a certain amount, so we have to meet those qualifications. Then, okay, what's the process? The science of process is a very simple process, okay? So it's a very simple basic thermodynamic is we use a Joule-Thomson valve, is an expansion valve that you can see here. So we have our LNG products from main cryogenic heat exchanger at very low temperature. So we will take it from main cryogenic heat exchanger, MCH. Then we will divide it to two parts. One part, we just send it directly to the storage tank, okay, without any separation of nitrogen. Okay, we have a side stream. And then we send the rest through a valve, a flow valve, where the pressure in the valve will decrease significantly. Once the pressure decreases, we will send it right away to a flash tank, LNG Flash Drum, that in this drum, the majority of nitrogen and light molecules like helium and also methane will be flashed off from the LNG product, which is in liquid phase, and then we get our liquid LNG products that is now rich and it doesn't have that much nitrogen and helium because most of them are rejected here. So we will send this to the storage. This stream from this side stream, LNG side stream, and this one, they go to storage. But for sure, they have different qualities. Here, this stream, since it doesn't go to the flash tank, it has more nitrogen than this one here. So it's a very simple process. As I said, the natural gas goes through a flash tank, through a valve and then flash tank, and that way helium, nitrogen, and even methane, they are flashed off from the LNG products, and they are in the vapor form, and they leave from top of the LNG flash drum, and this is called a flashing process. Then, okay, Actually, actually, the flashing is a partial vaporization. Okay, so flash drum is a partial vaporization. We send our mixture to the flash drum. Part of this mixture, which is usually in the liquid phase, it will be vaporized, and the rest will still remain in the liquid phase. One example is a can of paint. Okay, consider that we have can of spray paint. Okay, when you press the button here, so what you will do, you shoot out the paint. Okay, but after like after a while, you can, or after a few seconds, you can smell the drying agent. Okay, the drying agent. That what happens, both the paint and drying agent are together. They are together inside this can at high pressure. When they are flashed from this, from this valve, okay, so they are flashed out and the pressure decrease suddenly. And what will happen? The drying agent, which is a lighter agent, it will get vaporized. It gets separated from the remaining components, and that is how the drying process will happen. This flashing of those drying agent will accelerate the drying process. Okay. So when we do flashing through a valve, a flow valve, we call it here Joule-Thomson valve. So what will happen in this valve is kind of adiabatic valve, that the pressure decrease in the valve from 18 bar to about 1 bar. So before the valve, here I have pressure 18.3. After the valve, I have pressure 1.2. The pressure decrease. Not only pressure decrease, but also the temperature decreases. Before the valve, I have temperature about 1 minus 50 that is coming from the main cryogenic heat exchanger. After the valve, I have 1 minus 8. The adiabatic valve, the pressure and the temperature, both of them, they decrease. So now, okay, here I'm losing pressure. Okay, I'm losing pressure, but in the same time I'm getting a lower temperature, which is good for me, because creating a lower temperature, cooling in general, is an expensive process. So I'm spending, or I'm paying with my pressure, but I am getting lower temperature. So this lower temperature, which is the operating temperature of this flash drum as well, and both the vapor at the top and liquid, they have almost the same temperature. So I have a gas here, I have a vapor here at the top that is colder than my cryogenic heat exchanger, the ethylene from cryogenic heat exchanger. So I can maybe take advantage of this low temperature and send it to the heat exchanger to use in the previous cycle when I have a lot of refrigeration, I have mixed refrigeration. So I can use this temperature, this low temperature here is about minus 181, almost minus 182, and I can use it in the refrigeration cycle before this unit. Okay, so the fall in temperature here is used to cool the incoming mixed refrigeration, feed to the cold bundle of main cryogenic heat exchanger to further subcool the LNG product storage. So like here is saying that, so now I can use this vapor and I can contact it with a mixed refrigerant that is used in the cold bundle of the main cryogenic heat exchanger, one step before, and I can cool down that mixed refrigerant, because this mixed refrigerant, if you remember in unit 4, it goes to the main cryogenic heat exchanger. So I can cool down that one, and then take advantage of this low temperature here, cool it down, and then send this to the main cryogenic heat exchanger that goes to the cold bundle. Okay, and then once you send this vapor, cold vapor, to the heat exchanger, that will be in contact with the mixed refrigerant, and then after that it will be warm. So once it's warm, we will send it to a several stage of compression, and we have a vapor, we have a gas that is rich in nitrogen, but it's a fuel gas. It has also a large amount of methane and some helium and some other molecules. So we will compress it, and we will use a compression system that has also anti-surge controllers to compress this rich, we call it fuel gas. The gas from the top of this LNG flash drum, we call it fuel gas. Is a fuel gas which is rich in nitrogen, and we can use it for some other applications. Okay, so the LNG stream from the main cryogenic heat exchanger, from here, this part, okay, is flashed across a Joule-Thomson valve. So this valve here is a Joule-Thomson valve, this one here, that the pressure will decrease significantly. The pressure will decrease, and at the same time, temperature decrease from 1 minus 40 to minus 140 to minus 180. So then we have a two-phase stream that is separated in the LNG flash drum here. The flashing reduces the nitrogen content in the LNG product. So the LNG product that we have that is coming from main cryogenic, it will lose its nitrogen. Nitrogen will be separated. So the content of nitrogen will be much less. And that nitrogen content of this LNG product that is going to a storage now is less than what it has here in this state. So now it is ready for sale. It meets the specification that is needed by our customer, and then we can send it directly to the storage tank and then shipment. So the drum operates usually at temperature about minus 182, and pressure is 1 to 1.2 bars. Pressure is not very high, but temperature is very low. Then okay, the temperature of the LNG from the mixed refrigeration from the main cryogenic heat exchanger is controlled by the amount of LNG to the flash tank in order to produce the desired amount of flash gas. So here we have a side stream, as you can see. So the temperature of this LNG, okay, that is coming from the main cryogenic heat exchanger can be, in general, the temperature of the flash tank, okay, can be also kind of adjusted by the amount of LNG product, the LNG product that is coming from MCH to the flash tank. Okay, we can adjust it by we have also a side stream, so we can adjust it. And in that case, we can adjust the temperature of the flash tank and adjust the quality of fuel gas that we get at the top and the LNG product that we get here that goes to the storage. Then, okay, so after that, what we have? Okay, so this vapor here, which is cold at temperature about minus 182 or minus 180 or 82 degrees C, which is very cold. It has a very good value because it's a cold, like creating cold temperature is much more expensive than creating a high temperature. So bringing the temperature to a lower temperature is more expensive than increasing the temperature. Okay, let's say for increasing the temperature of this room here, I just can put a heater, electrical heater, you know, like electrical element heater, and which is not expensive. I can even make it by myself, you know. It's just a piece of metal, you know. For sure I'm not gonna do it, but and I don't suggest that you do it. But it's as simple as that. But creating a lower temperature, bringing the temperature of this room to a lower temperature, it needs a AC that has an evaporator, condenser, compressor, expansion valve, pump, you know, like a lot of electrical, you know, like devices, equipment all together. Okay, so creating a cold temperature is much expensive than creating a higher temperature. So, okay, this gas here has a good value because it is in low temperature and we can do a lot of things with it. So what we do, we will send it to a heat exchanger. What is that heat exchanger? Next slide. We will send it here. That is the gas coming from the top of the flash tank. This gas, the arrow that just let me, yeah, the arrow that I that I have shown in the previous slide is coming to this equipment. What is this equipment? Is a heat exchanger that we have our cold fuel gas coming from the top of the LNG flash drum. It goes through this heat exchanger and it absorbs the heat and it becomes warm. Here it is cold, here it becomes warm. So from which component, from which stream is absorbing the heat? Is absorbing the heat from the mixed refrigerant. The mixed refrigerant that is coming from the high pressure compressor. So please, look at your unit 4. I think I have one slide here for you. Unit 4. You remember unit 4 when we talk about the last part of the last part of the unit 4. I talk about this part. So that is the flash. That is the flash tank that I was talking about. So the flash tank that we had. So the flash tank that we had. We send our LNG products, okay, and we have fuel gas, okay. Okay, what we do? We send our vapor from the LNG flash tank, the vapor from LNG flash tank in this heat exchanger, and then we will have cold vapor, cold LNG flash drum vapors that goes to the heat exchanger and it becomes warm, okay. But it will be in contact with which stream? It will be in contact with the mixed refrigerant stream, okay, that is going to the cold bundle. It's coming from -34 and it leaves at -61, okay. Mixed refrigerant that is coming from the another unit, from compressor, evaporator, and we cool it down. We make it -161 to the liquid phase, and we send it to the cold bundle of main heat exchanger, main cryogenic heat exchanger. This is coming from the mixed refrigeration cycle from the high pressure compressor or evaporator. And then we will send it to this heat exchanger. So this heat exchanger, the yellow that you see is this one here in this photo. Okay. So let me go back again to this slide. Okay. So let's continue here. So now this vapor, okay, the cold vapor that is leaving the flash tank, the fuel gas, the cold fuel gas, will be used to cool down the mixed refrigerant in this heat exchanger. The mixed refrigerant, which is warm, Warm, it means minus 34, as you saw in the slide here that I showed you. Okay, this one here. So it will be cold, and then it will be sent to the main cryogenic heat exchanger in the cold bundle. The cold bundle are here at the top. All right. After, okay, the mixed refrigerant that will be cold from minus 34 to minus 161. Here is minus 34 almost. Here is minus 161. It goes to the cold bundle of like here, this part. It goes to the cold bundle of main cryogenic heat exchanger. That here it will, in the heat exchanger, it will be in contact with the methane, with the steam natural gas that is majority methane, and it will cool down the methane, okay, that produce our LNG product, okay, produce our LNG product. That LNG product will go to the storage, okay. So the fuel gas, after that, now we have a warm fuel gas in the vapor phase. We have to now compress it, and we have to storage in a tank. Okay. So now that warm. Okay, let me explain it here. Maybe it's better. Okay, both figures, this one and this one, they are almost the same. But I will use this one to explain, which is better, because almost all the slide in the other side have this process. So that warm flash gas, fuel gas, okay, that is coming from the heat exchanger. So that warm flash gas, now we have to compress it, and at the end we have to send it to the fuel gas system or fuel gas storage. From here to here, we have from warm warm fuel gas or flash gas, to fuel gas system or fuel gas storage. There are several steps of compression that I'm going to talk a little bit about that. So this train, we call it the fuel gas system. Okay, the fuel gas system, the fuel gas, the one fuel gas will go through these steps, and it will be, at the end, it will be stored. So what we have, so I said that the fuel gas from the top of the LNG flash drum, it is cold. It goes to the heat exchanger. It will cool down the mixed refrigerant. This mixed refrigerant goes to the main cryogenic heat exchanger. The main cryogenic heat exchanger is okay. Let me plot it in the better way. Okay, so it goes here, main cryogenic heat exchanger. Okay, so this, then once it's cooled down, this mixed refrigerant, it will be warm. Now it's warm. I have to send it to compression system and compress it, and then I will use it or restore it, or I will send it to another unit. So the vapor from the LNG flash tank is heated in the fuel gas and mixed refrigeration. Green is fuel gas stream, and blue is mixed refrigeration. Okay, in the liquefaction unit by high pressure mixed refrigerant vapor from the high pressure mixed refrigerant separator. Okay, so it's coming from because this is in unit 4, we already talked about that mixed refrigerant goes to several steps of compression, separator, flash drum, and then it will be sent to the cold bundle, right? So like the mixed refrigerant here is coming from high pressure mixed refrigerant separator, is coming from that step. It's this one here. Then the warm flash gas. Okay, now Now we are going to, I'm going to use this figure more to explain. Now, the warm flash gas is introduced to the low pressure fuel gas compressor suction drum. Low pressure fuel gas compressor suction drum. So this is your warm fuel gas stream, warm flash gas or fuel gas that is going to this suction drum. Since then, we have here two compressor train. One is low pressure up to here, is low pressure, and this train is high pressure. It's like each of them there are two stages. This has two stages of low pressure. This one has also two stage of high pressure. So it goes to this suction drum. Warm fuel gas goes to this suction drum. In this suction drum, if there is any liquid, it will be separated. If there is any liquid, it will be separated in this suction drum. If not, the vapor goes to low pressure fuel gas compressor. Okay, so the vapor from the top of this drum, this suction drum, goes to the low pressure fuel gas compressor first stage. Okay, as I said, in the low pressure compressor, we have two stages. Here we have also two stage. Okay, so it goes to the first stage, and after the first stage, like after here, the pressure will be almost 4 bar. After that, so now it is gone to the first compressor. Now is almost 3.9 bars. Now it goes to the cooler. Okay, a cooler system to cool down the temperature. Now, okay, the stream from the compressor first stage, here it means first stage, it means here, is cooled by a fresh cooling water in the low pressure fuel gas compressor intercooler. It means this one. Intercooler is this one. So after it goes to the first stage of the compressor, it goes to almost 4 bars. Now the temperature is high. We send it to the intercooler, this intercooler, and we decrease the temperature, and then we send it to interstage drum. We call this interstage drum. In the interstage drum, why we do it? If there is any liquid, we will separate it in this interstage drum, like what we do in the suction drum. After interstage drum, it will be again sent to the second stage of low pressure fuel gas compressor. First stage, this is first stage, this is now second stage. Second stage of low pressure fuel gas compressor, low pressure fuel gas compressor. So it will be sent then, and then after that, it will be the pressure will increase at the exit that we will see in the next slide. So the vapor from the low pressure interstage drum, it means here, is sent to the low pressure fuel gas compressor second stage. As I said, after the interstage here, it goes to the second stage, and the pressure will increase up to 7.7 bar. So now my vapor here is at 7.7. Almost the pressure almost increased twice. In all of the stages, here we have two stages, low pressure. In the high pressure, we have also two stages. Okay, in both stages, I can say in all of this stage, the pressure will just get double. You know, like we increase the pressure twice. Let's say here we have 2 bars. It goes to the 4, and then after 4, almost 7, almost 8 here, and then 16, and almost 24, 28 something. Let's say almost twice, not exact. So after that, here now my vapor is 7.7 bar here at this exit. And again, what I will do, I will send it to a intercooler, aftercooler. So suction drum, intercooler, interstage drum, aftercooler. So the stream from the second stage is cooled by fresh cooling water in the low pressure fuel gas compressor after cooler. Low pressure fuel gas compressor after cooler. Low pressure fuel gas compressor after cooler. It will be cold. It will be cooled down here, and then it goes to the suction drum of high pressure fuel gas compressor. So after this, after cooler, it goes through this line and it goes to the suction drum of high pressure compressor, fuel gas compressor. You see, like there are some recycle streams that are mainly for anti-surge system, okay, to avoid the surge. So now let me clean it, because now we are in the high pressure part, high pressure fuel gas compressor. We already passed this part here. Now we are in the second part. We are in this part. So now it goes to the suction drum of the high pressure fuel gas compressor. So after that, after suction drum, okay, it will be after suction drum of high pressure fuel compressor. It will, here why we use a suction drum again, to remove any in-terrain liquid. Then once we separate the liquid, we will send it to the high pressure compressor. This compressor, high pressure compressor, has again two stage, first stage and second stage, okay, two stage compressor. In the first stage, the pressure reached to, as I said, it gets almost double, okay? It reached to 14.4 bars, and now is here it was 7.7, now here is 14.4. Now it goes to the intercooler, like any, for any compression system, like with two stage or two compressor, we usually have an intercooler between the two compressor or two compression stage. We have an intercooler to decrease the temperature. Otherwise, the efficiency of compression won't be that high. Okay, so just let me clean it a bit again. So now, after the first stage of high pressure compressor, we send it to the intercooler, and then it goes to the interstage drum, like exactly like previous, the low pressure compressor. So after intercooler, the temperature decrease, and now it goes to the interstage drum to remove any liquid, any possible liquid. Okay, after we remove the liquid, now we will send the vapor to the last stage, to the second stage of high pressure fuel gas compressor. So after intercooler, it goes to the high pressure fuel gas compressor interstage drum. And after that, after this interstage drum, it goes to the second stage compression, where the pressure from 14.4 here, it was 14.4, 14.4. Now it reached here to which temperature? It goes through the second stage, and it leaves at pressure about 26.5. As I said, it gets almost 12. So here it leaves at 14.4. It goes to the it goes to after intercooler and interstage. Then it goes to the second stage of compression, and it leaves at 26.5 bars. Okay, and after that, it goes to a aftercooler, and then a storage. So the stream from the second stage high pressure fuel compressor, it means from here, this part, it is cooled by a fresh cooling water in a high pressure fuel gas compressor after cooler. It means this one. So after the second stage here, this part, it goes to the after cooler, and then it is sent to fuel gas system, fuel gas unit. Okay. So that was pretty much this unit. As you saw, it was a kind of short unit, and I hope you learn a lot of things with it, and I hope it was not that complicated for you. So the objective, I mean, this is a typical fuel gas system, okay, that usually produce about 50,000 kilogram per hour of fuel gas or flash gas. So here at the end, we have almost 50,000 kilogram per hour of fuel gas or flash gas. Okay. Another point is the low pressure and high pressure fuel gas compressors. These two compressors, that each of them are two stages. They are they are not a complicated compressor. They are a single shaft compressor that driven by electrical motor. Okay, so these two compressors here, they are single shaft and they are driven by electrical motor. And okay, and last slide is kind of a typical LNG production plant, okay, that is producing about 300 tons per hour of LNG product, okay, in the summer night. Is the LNG plant that is producing 300 tons per hour of LNG product. So those are some specification of the different units and the flow rate. So the exit of main cryogenic heat exchanger, the flow rate is more than 400,000 kilogram per hour. Okay, that it's arriving at pressure 20 bars, temperature minus 150. Then it goes to the flash drum. Okay, the same stream goes to the flash drum. In the flash drum, we have two parts. We have top products or overhead products, and we have bottom. In the flash drum, first of all, the pressure decreased significantly, and in the same time, temperature decreased significantly. So this is before the flash drum, this stream, you right to the inlet, and this is inside or after the flash drum, that the vapor lives at the top and liquid lives at the bottom, okay, at a very, very low temperature. And at the end, as I said, we send this flash gas overhead, which is our fuel gas or flash gas. We will send it to the heat exchanger and then two compressor train. And at the end, we have our fuel gas that goes to the fuel gas system or fuel gas mixing drum. And the amount is about 50,000 kilogram per hour, pressure 27 bar, and temperature almost 47. Okay, so this table very nicely shows how the operating condition change from one step to another one. So that was all for us for today, and hope you enjoyed.